This is Sketching Trig Functions Part 2. Now in this page we are dealing with vertical translations. Now for this question, we first need to find the x-intercepts for each graph. So let's let y equals 0. Zero equals 2 sine x plus 1. Negative 1 equals 2 sine x. Negative 1/2 equals sine x. Now if we think about the not the unit circle, the special triangles, we know that negative 1/2, the reference angle for this would be, ref angle is pi on 6. Now sine pi on 6 is negative in the third and fourth quadrants, right? So because we aren't dealing with a dilation over here, a dilation relative to the y-axis, we find all the solutions that are within 0 to 2 pi. Now, okay, sine x equals 3 pi on 6 plus pi on 6. No, let me make this easier. Pi on 6 plus pi on 6 and 2 pi minus pi on 6. X equals, what is this? 7 pi on 6 and 11 pi on 6. Now let's sketch this up. 2 sine x plus 1. Now over here we have an amplitude of 2 and a translation upwards by a factor of 1. So let's write this up here. 1. Okay, 1, 3, and negative 1. Now we start from the origin and we've got two solutions, 7 pi on 6 and 11 pi on 6. Alright, let's do this. And we have a period of 2 pi, yes. 7 pi on 6 is approximately here, and 11 pi on 6 is approximately here. Okay, 1. Now, okay. Okay, let's get this about halfway. Halfway is around here. So 7 pi on 6 divided by 2 equals 7 pi on 12. So, okay, this is just over pi on 2. Let's say this is pi on 2, this is 7 pi on 12. 7 pi on 12. Let's get this approximately here. Amplitude peaks around there. And then 7 pi on 6. Now 7 pi on 6 to 11 pi on 6, the gap is 5 pi on 6, so okay. Let's do the same. It's 7 pi on 12, so let's do that. Okay. 11 pi on 6 minus 7 pi on 6 divided by 2 equals 4 pi on 6 divided by 2, which equals 4 pi on 12, which equals pi on 3. Oh, sorry, this is 2 pi on 6. Yes, 2 pi on 6. So we just add 7 pi on 6 plus 2 pi on 6 equals 9 pi on 6. Right, 9 pi on 6 is approximately, let's say, halfway. 9 pi on 6. Let's put our minimum point here. And then we end at 11 pi on 6. Now, because our domain is constricted to 0 to 2 pi, let's write y of 2 pi. Let's find what the point is here at 2 pi. Now y of 2 pi equals 2 sine 2 pi plus 1. Plus 1, my mistake. 2 pi plus 1. At sine 2 pi, sine is 0, so this equals 2 0 plus 1. This equals 1, so our final point here is here. Let me draw this a bit neater. Okay, so this final point is 2 pi and 1. Next one. y equals 2 sine 2x minus root 3. Now let's find the intercepts. 0, okay, x intercepts. Let y equals 0 again, equals 0 equals 2 sine 2x minus root 3. Root 3 equals 2 sine 2x, and root 3 on 2 equals sine 2x. Now the reference angle here is pi on 3, and sine pi on 3 is positive in the first and second quadrant. Right? Now we've got a dilation relative to the y-axis by 1.5 over here. Now to deal with this, we need to adjust the domain. Our existing domain is 0 is less than or equal to x, which is less than or equal to 2 pi. Now to consider all the solutions relative to this dilation, we need to apply the same dilation to the existing domain. So let's multiply 2 by both sides, to each side, times 2, times 2, times 2. 0 is less than or equal to 2x, which is less than or equal to 4 pi. Now let's let 2x equal theta. Now theta within this domain, let me just fix this, 4 pi. Now theta within 4 pi, we need to find all the solutions where pi on 3, sine pi on 3 is found. So okay, pi on 3, 2 pi on 3, let's draw a diagram here. Got pi on 3, 2 pi on 3, we got full revolution, so pi on 3 plus 2 pi gets us 4 pi on 3, and then 5 pi on 3. Now let's write the exact value of theta 2x equals pi on 3, 2 pi on 3, 4 pi on 3, and yeah, sorry, my mistake. Pi, let's just do the full working. Pi on 3 plus 2 pi, 2 pi on 3 plus 2 pi, my mistake, guys, equals pi on 3, 2 pi on 3, 6. This is 6 pi on 3, so 7 pi on 3, 8 pi on 3. Sorry, guys. Okay, let's do this again. 2x equals pi on 3, 2 pi on 3, 7 pi on 3, and 8 pi on 3. Now x, let's divide all these values by 2 to find the values of x. X equals pi on 6, 2 pi on 6, 7 pi on 6, and 8 pi on 6. Let's simplify all these solutions. X equals pi on 6, pi on 3, 7 pi on 6, and 4 pi on 3. Okay, let's sketch this up. No translation here, just a dilation. So our period is pi. Our amplitude is 2. Amplitude equals 2. Translation negative root 3. Negative root 3. Okay, let's get this. Okay. This is negative root 3. Amplitude is 2, so this is negative 2 minus root 3. Negative root 3 plus 2 is, let's say, approximately here. Negative root 3 plus 2. Let's get this. Okay. Pi on 6. Okay, we start here. Our first value is pi on 6. Then our next value is pi on 3. Pi on 3 is approximately here. So let's just bring this up here. Pi on 3. Okay, let me just write the value here. This value here is 2 pi on 6 minus pi on 6. So this is pi on 12. This is 2 pi on 12 plus pi on 12, which equals 3 pi on 12, which equals pi on 4. This first point here, the minimum occurs at pi on 4. Pi on 4, let's label this point. Pi on 4, negative root 3 plus 2. Now you can write this 2 minus root 3, negative root 3 plus 2. Doesn't matter. Pi on 4, negative root 3 on 2. Next point. The next point is 7 pi on 6. Now 7 pi on 6 lies approximately here. 7 pi on 6. Let's erase this. Now the distance between pi on 3 and 7 pi on 6. 7 pi on 6 minus 2 pi on 6 equals 5 pi on 6. Now 5 pi on 6 divided by 2 equals 5 pi on 12. Now 5 pi on 12 is just below, okay, 6 pi on 12 is pi on 2, so 5 pi on 12 should lie around here. 5 pi on 12. This is, okay, 5 pi on 12. This is approximately pi on 2. Let's erase this, make some room. 5 pi on 12 at the minimum point, and 7 pi on 6. Okay, wait, let me just fix this up. And 7 pi on 6. Okay, 7 pi on 6, 4 pi on 6, that's approximately 8 pi on 6. 8 pi on 6, let's say, is approximately here. 4 pi on 3. Right here. 4 pi on 3. Oh, sorry, no. 4 pi on 3. Let's make this here. 4 pi on 3. And maximum point is around here. Now the midpoint here is 7 pi on 6, which is 14 pi on 12, plus pi on 12, which is 15 pi on 12. And now, because our domain is within 2 pi, we need to find the value of 2 pi at this point. So f of 2 pi, y of 2 pi, function, yep, y of 2 pi equals 2 sine 2 pi minus root 3. Sine 4 pi is 0, so 2, 0, minus root 3. This equals a negative root 3. Our final point lies around here. This equals 2 pi, negative root 3. Don't mind the sketch, guys. It's not to scale, but this is approximately what it should be. Now for root 2 cosine x plus 1. Now with this function here, we have no dilation relative to the y-axis. We have a dilation relative to the x-axis by root 2. Our amplitude becomes root 2. and our translation is 1 unit up from the y-axis. Okay, let's find the solutions. Because we have no dilation here, all our solutions remain within 2 pi, so there's no need to adjust the domain. Let's find these solutions. X-intercept is 2, y equals 0, this equals 0 equals root 2 cosine x plus 1. Negative 1 over root 2 is cosine x. Cosine x. Now the reference angle here is pi on 4, and cosine pi on 4 is negative in the third and fourth quadrants. Now, to make this easier, just remember, memorize the unit circle and the special triangles, if you want to do it as quick as I can, okay? Cosine x equals negative 1 root 2 over 2. Pi on 4 is the reference angle. X equals 3 pi on 4 and 5 pi on 4. This is a cosine function. The translation is plus 1 up, root 2 is the amplitude. Sketch this right here. 1 plus root 2, 1 minus root 2. Okay, let's say this is pi. Space this out. Our first point is 3 pi on 4, and the second point is 5 pi on 4. Let's draw this out. 5 pi on 4, our minimum point is at pi, because our next intercept is 5 pi on 4, right here. Now because we don't know the value of 2 pi at this point, we need to sub it in. Y equals root 2 cosine 2 pi plus 1. At cosine 2 pi, the solution is 1. Y equals root 2 plus 1, which is right here. So let's put this right here. That's it. 2 pi and 1 plus root 2.